Hello and good day, Algebra. We are going over part 2 of CO41, continuing our journey with systems of equations. In CO40, we talked about solving a system when graphing. Graphing a system can be very efficient when they're already in slope-intercept form for you, or you've got a corner plane to work with. CO41, we started talking about the substitution method, where if you can isolate one of the variables in the system, you can then substitute that value in for the variable in the other equation, which will give you one equation, one variable to solve for, which is what you need. Part 2, you get to set the system up yourself. So let's take a look. It says you burned 8 calories per minute shoveling snow and 10 calories per minute throwing snowballs at your friends for a total of 560 calories burned in 60 minutes. How many minutes did you spend doing each activity? Okay. Now, like we talked about, the reason why this is a system is there are lots of different ways, and you don't have to write this part down yet, but there are lots of different ways to spend 60 minutes doing two things, right? You could spend 1 minute shoveling and 59 minutes throwing snowballs. You could spend 2 minutes shoveling and 58 minutes throwing snowballs, right? And on and on and on and on and on. But with the second condition, that second variable with how many calories burned, this is where we've got to figure out what combination of add-ins to make 60 will also get us 560 calories burned. And that's why you need a system, because we're solving for two things here, okay? Calories burned and minutes. So how you set this up, I'm going to give you a process. I will use this same process for the first several. Once you kind of get the gist of it, you can shorten the steps for yourself. But the first thing we're going to do is we are going to identify our variables. We can't really set up equations if we don't know what we're solving for, okay? And your variables will usually be in the question, right? Because if you're solving for something you don't know, you have to be asked what that is, okay? So it says, how many minutes did you spend doing each activity? What activities are we talking about here? Caitlin?
Shoveling snow.
Shoveling snow and throwing snow. So our two variables, the first one, we want to know how long we spent shoveling. Hopefully you didn't throw out your back, okay? And we want to know how many minutes we spend throwing, right? Those are the two things that we're solving for. And you can use whatever variables you want to. S and T might be the best because it's kind of contextually appropriate. If you want to stick with X and Y because you're more familiar with them, doesn't really make a difference. But we will use S, and I will take great care to make sure my S does not look like a 5. Look at that, right? And we will use T for our two variables. Okay? Yeah, thank you. S and T. Minutes shoveling and minutes throwing. Yes?
Why on the T does it look like a triangle?
Because I've been told that if I just use the T as a variable, the way it looks like a plus sign.
It does.
It does. That's why I put the little tickle in there. See? I'm constantly evolving, constantly changing, accommodating the needs of my students. Did you hear that, boss? That's me. Okay. So identify the variables, minutes shoveling and minutes throwing. Step 2, we need to identify our totals. Okay? Because every equation has a total, right? It's got to equal something. So again, because we have two equations, there are going to be two totals. Can you figure out what those totals are? Nathan, give me one.
60 and 500.
Sorry?
60.
Okay, 60, and that refers to what? Minutes. That's kind of our units here. Okay, and what's the other one? Maddie?
560 calories.
560, and that refers to the calories. Okay. So now that we've got this part figured out, now we can set up the equations themselves. Okay? We know that one total is going to be 60. So one of my equations will equal 60. And I wrote the units next to the 60 here. Just remind me, what makes up this 60? Minutes. Minutes doing what? Minutes shoveling. Oh, that's one of our variables. So the number of minutes shoveling plus the number of minutes throwing, which is our other variable, equals 60. Okay? Not yet, because if we're solving for the minutes shoveling and minutes throwing, and this first equation has to do with minutes, we have to make sure our units kind of match up here, right? And that's why in the margin to start, I had 1 and 59, 2 and 58, right? If we spent 1 minute shoveling and 59 minutes throwing, that equals 60 minutes doing something. Okay? Our second equation, the total is 560. And what unit is that 560? Calories. Okay. How are we going to represent burning 8 calories per minute shoveling and 10 calories per minute throwing? Okay?
8s and 10s.
Remember that word per, along with each and every, can mean that you're multiplying, right? So 8 minutes, or 8 calories per minute shoveling, 8s, plus 10 calories per minute throwing equals 560 calories. Okay? So, if we had gone back to what I wrote in the margin, where, well, what if you spent 1 minute shoveling and 59 minutes throwing? Okay? Does 1 plus 59 equal 60?
Yeah.
Yes. However, and again, don't have to write this down, if I spent 1 minute shoveling, I would have burned 8 calories, right?
Mm-hmm.
If I spent 59 minutes throwing, how many calories would I burn?
590.
590. Well,
590.
1 and 59 isn't the solution because it doesn't fit the second equation as well. Okay? So that's why we have to solve the system together so that we are looking for something that works in both the minutes and the calories. Now that we've done this, it's exactly the same as you did previously, right? Do you want to isolate S or isolate T?
T.
T, okay. So we're going to move S over to the other side here, and because we're moving it, we have to use opposite operations, subtract S from both sides, and the equation that we get is T is equal to negative S plus 60. Right? This is the same as CO41 part 1 now. Once you write the system, the solving doesn't change from what you were doing yesterday and what you had for homework. That being said, we are using different variables. This is kind of a different thing. Do you have any questions? How I got to where I'm at? Yeah.
No, I was wondering, can we make the S, X, and the T, Y if we want to?
It does not matter what letters that you use. I recommend picking something that's in context with the question. Otherwise, you might confuse what X means, what Y means, right? If you solve for T, it helps the brain remember, oh, that's throwing, because throwing starts with T, right? Nick.
So if we were to move so could we also, let's say we wanted to move the T, could we move the T and would it still be right?
You can move it, just don't spill it. But yes, right? Then it would be S equals negative T plus 60. Wasn't that a funny joke?
Yeah.
Spilling the
No.
Eli.
Do we have to show the whole process of how we got there at test?
On the test? No.
Yeah.
No, we have it down here so you can see it. Once you start doing these on your own, you have to show some work, right? But the steps that you skip because you understand them, that's fine, okay? Before we get too far off, let's finish solving this, okay? Do you have questions about?
No, I was going to ask her.
Okay, so now that T is by itself, it equals negative S plus 60. What do we do with that? What's our next step here? Nick?
Divide by 10.
Nope. Manny?
You want to put that equation into that equation.
Right.
So you go 8s plus 10, and then do minus, in parentheses, negative S plus 60 equals 560.
Right. We go to our second equation and we substitute the value for t in for the variable t in that other equation, just like you were doing yesterday. Okay? Now we distribute. We get 8s minus 10s. Don't forget about that sign. Don't lose that sign there. Okay? Plus 600 equals 560. Combine like terms, 8s and negative 10s is a negative 2s. Plus 600 equals 560. I'm going to move this over here now so I have some more space to work. Okay. What would my next step be? Subtract 600. We get negative 2s equals negative 40. Divide by negative 2 to get s by itself. And s equals 20. Okay. S equals 20. Which means if we spend 20 minutes shoveling, how many minutes did we spend throwing, Colin? 40, right? So S is 20, T is 40, that equals 60. If we plug these values into our second equation also, spend 8 calories per minute shoveling, that's 160 calories. We burn 10 calories per minute throwing, that's 400 calories. And 160 plus 400, bingo, checks out the second equation as well. Okay? So this is the one combination here that's going to work in both of them. S is 20 and T is 40. Okay? Now, the nice thing about word problems with context is that certain answers won't make sense. If you somehow lost a negative sign somewhere here and you got like negative 20 as an answer, that should ring the alarm bells that you did something wrong. Because how can you spend negative 20 minutes doing something? It doesn't make any sense. Okay? Right? We're pretty much locked into somewhere between 0 and 60. Okay? Negatives wouldn't make any sense. Anything greater than 60 wouldn't make any sense. Right? So the advantage to these word problems here with the context is that it does give you somewhat of a range for your answers. Yeah, Nick?
How does negative 2s equal negative 40?
We subtracted 600 from both sides here to cancel this out, and then 560 minus 600 is negative 40. Maddie? Not right now. We're kind of running short on time. I want to make sure that we get. Okay, what's that? Not the whole thing. Oh no. This is good. This is a multi-day thing. Questions on this one?
Can you just help us set up the next one?
Yeah.
Yeah,
Yep,
please.
yep, yep, yep.
Please.
I just need to set it up.
You can check your answers. If you're working ahead and you want to write, check your answers. Anything with this? Okay. Next one. What's the situation here? The members of an outing club take a day-long tubing trip down a river. The company that offers the tubing trip charges $15 to rent a tube for a person and $7.50 to rent a cooler tube, Sam, which has nothing to do with the social status of the tube. It is simply meant for a cooler. Okay. The club members spend $360 to rent a total of 26 tubes. How many of each type of tube do they rent? Step 1. What are our variables? What are we solving for? And remember, to find these, look in the question. Tristan? Okay, so our first variable, we have a person tube, okay, which we'll use P for that, and a cooler tube, and we'll use C for that. If you want to use X and Y, A and B, M and N, doesn't really make a difference. But with P and C, you can remember kind of what you're talking about here. And again, how Tristan found that is how many of each type of tube? Oh, types of tubes, how many are there? There's a person tube and a cooler tube. That must be what I'm solving for, right? Step 2, we're going to set up the totals. Okay? What are the totals in this situation? I'd like to see all the hands up. Very good. Joseph?
The 26 tubes.
Okay. 26, which refers to the tubes. That's our units, right? So one equation will equal 26 and talk about the tubes, like the physical tubes, how many tubes, and the other? $360. Okay, and so our second equation will have a total of 360, and that's going to refer to the cost of the tubes, right? The dollars, what's being spent. All right, I'm going to have you take it from here, solo, set up the rest of the equations, do the solving. Mr. Link is here to help out. I'm here to help out, kind of walk around, see how things are coming along. If you get an answer, check it yourself first. And then if it doesn't work and you can't figure out your mistake, then ask for help, right? Because these are equations. You can check your answers, okay? Check your answers. In this case, would a decimal answer make any sense?
No.
Why not?
Because you can't rent a decimal.
You can't rent a part of a tube, right? Okay. Would a negative answer make any sense? Why not? You can't purchase a negative amount of tubes, or you can't spend a negative amount of dollars. Okay. What's that? Buy them tubes?
Yes.
Donate tubes to the club? Perhaps. So if you get a negative answer, check your work. It's not correct. If you get a decimal answer, check your work. It's not correct. Right? They don't make any sense here. So finish this. No other homework for tomorrow, but I'll end the video here. That's how you math.
It's